Hey, Algebra 2. Today we're going to learn how to simplify using our laws of exponents. So most of these are going to be monomials. Monomial is either a number, a variable, or the produce. Oh, that's fun. That's supposed to be the product. So such as 3xy, that is a monomial. 7a squared b is also one. A power is the combination of a base and its exponent. So the 2 is the exponent, and the 5 is called the base. So here we have our rules of exponents. So we have the product of power. So if you are multiplying two variables and they have the same base, you just simply add the exponents. All right, so 5 to the second and 5 to the sixth, they have the same base. And so this rule says if you have the same base, you add the exponents. And so therefore you get 5 to the 8th. That 8 is supposed to be an exponent, by the way. Here, my bases are variables. This y that does not have an exponent, there's always an implied 1 there. So you add the exponents. 4 plus 3 plus 1 would give you y to the 8th. On the next ones, so I'm going to move things around and I'm going to group basically the like terms together. I'm going to group the coefficients together and I'm going to group the variables together. Numbers multiplied as they have always multiplied. When you multiply variables, you add exponents. This is 42y to the 6th. Right here, I'm going to move everything around. I'm going to group and multiply the coefficients together. I'm going to group the x's together, and I'm going to group the y's together. Numbers multiply. When you multiply variables, you add exponents. There we go. When you have the quotient, quotient means that you have a division problem here. So the quotient of power says that when you divide, you subtract, and today we're going to go top minus bottom. All right, so I have y to the 6th divided by y. There's an invisible 1 there. And so when you subtract, sometimes I just do it like that, I cross it out. 6 minus 1 equals 5. That is y to the 5th. I have the same base, so I subtract the exponents. So you just have to go 13 minus 2 is 6 to the 11th. All right, so here we have coefficients and we have a's and b's. Your numbers divide and simplify as they always have. Your variables, you are going to subtract. I'm just going to rewrite this to give myself a little bit more room. 10a to the 7th, b to the 9th, divided by 15, a to the 5th, b to the 9th. All right, so 10 divided by 15, well, you can't, but there is a factor of 5. So I would divide a 5 out of the numerator and denominator. That's going to simplify to 2/3. Variables you subtract. We're going to go 7 minus 5. And here, when you subtract 9 minus 9, you're going to get 0. Or you just need to recognize anything divided by itself always cancels out and equals 1. All right, so across the numerator, I have this coefficient of 2. A to the 2nd, and in the denominator I still have that 3. That is how that one would simplify. We have the 0 exponent rule. So anything raised to the 0 power equals 1 by definition. So 6 to the 0 equals 1. A bunch of stuff raised to the 0 power equals 1. All right, so on this last one, only the x is being raised to the 0 power. So x to the 0 is 1, but you have to multiply it by this 8. So now I have 8 times 1 plus 5. 8 plus 5 equals 13 for a good final answer on that one. The next section is called negative exponents. So we like to know how to fix negative exponents, and basically wherever it's negative, you flip it and you move it and you move it. So here, a to the negative m is negative in the numerator. So we're going to send that to the denominator, and now it goes positive. Here I have 1 over a to the negative m, so the exponent is negative in the denominator, so you send it up to the numerator, and now it goes positive. All right, so if I have 2 to the negative 3, that is implied to be over 1. So I'm going to send that downstairs, and now I have 2 to the third in the denominator. You just need a placeholder, and so 2 to the third power equals 8. Here I have 3 to the negative 3, that is implied to be over 1. That term moves to the denominator, so I have negative 3 to the third power. You need a placeholder, so you have 1 in the numerator. All right, so note what happened. I had both a negative base and I had a negative exponent. When you send it down and you move it, only the exponent changes. The base, the number itself, never ever changes. And negative 3 to the third power is negative 27. All right, so now we have a couple of power rules coming up. So we have a power to a power. Okay, so a power to a power means that you have something in parentheses raised to an exponent, and then that is also raised to an exponent. And the rule here says that you multiply these exponents together. So that means that you have x to the 2 times 8 power, which gives you x to the 16. Here, when you have a negative times a negative, that gives you a positive 12. You multiply those exponents. The power of a product just means that you're going to have multiple terms inside raised to an exponent. And you kind of need to think of it as distributing. So whatever this exponent is, it needs to be distributed to everything inside of it. All right, so you have to raise the 4 to the third power. You have to raise the x cubed to the third power, the y to the third power, and the z to the third power. If you have a number raised to an exponent, you need to give me just one single number. So that is 64. Here you need to follow your prior rule. You have an exponent to an exponent, means you multiply them. That gives you x to the 9th. You can't do anything with the others other than just write it down. That's your good final answer. All right, so now I have an exponent of negative 2. I'm going to distribute it to every single term. So now you have 7 to the negative 2. You have x to the negative 2. And then you have y to the negative 2 raised to the negative 2. So I'm going to deal with this first. When you have an exponent to an exponent, we multiply them, and negative times negative goes positive 4. All right, so when I did that, I left myself with 2 negative numbers here. All this is implied to be over 1. So you aren't allowed to leave negative exponents in your final answer. So this 7 to the negative 2 needs to move down to the denominator. Now it's 7 to the positive 2. X to the negative 2 moves to the denominator. And y to the 4th was fine. It's a positive exponent. It needs to stay where it is. My last move, I'm just going to square the 7. So you would have y to the 4th over 49x squared for a good final answer on that one. All right, I need to distribute the negative 2 to all these terms. 6 to the negative 2. On the x, you have negative 6 times negative 2, which gives you positive 12. Distribute it to the y term. You have an exponent raised to an exponent, so you multiply again. And then you have the z, 0 times anything equals 0. All right. X to the negative 2, I need to send that down to the denominator. So 6 to the second is in the denominator now. The x to the 12th and the y to the 14th will always find right where they are. We learned a minute ago that anything raised to the 0 power is just simply 1. And so now this is almost good. I'm just going to x to the 12th, y to the 14th, 6 squared is 36 for a good final answer on that one. Here you have the power of a quotient. So now you have a fraction raised to an exponent, and this just says basically that you have to distribute it to everything in both the numerator and the denominator. So I'm going to raise the 3 to the second power and the 5 to the second power. 3 to the second power, 5 to the second power. 3 squared is 9, 5 squared is 25. All right, on the next one, every single thing inside the parenthesis needs raised to the second power. So in the numerator, I have 2 to the second power. I have a to the 5th to the second power. And in the denominator, I have b to the 7th to the second power. 2 squared is 4. A to the 5th squared, you multiply those and you get a to the 10th. Multiply those and you get b to the 14th. Good final answer. The next two, you would just do the same thing, distribute, and then fix any of your negatives. I'm going to do the last one. So on the last one, we have a lot of things going on. We have both A's and B's in the numerator and denominator. So let's see what we can simplify. So I'm going to simplify everything in my numerator first. I'm going to leave my 25 alone. A to the third to the third. So exponent raised to an exponent means you multiply. I have a to the 9th. And then b to the 2nd. In the denominator, I just have the one number. I just have the one a, so I'm just going to rewrite it for a minute. But in the denominator, I have two b's. So b times b to the 2nd. When you multiply variables, you add exponents, and that gets you b to the 3rd. Numbers divide like they've always divided. So now you need to simplify this so that all of your numbers are simplified and your variable you only see one time. 25 divided by 5 is 5, so that's going to give me a 5 in the numerator. When you divide variables, you subtract exponents. Subtract exponents. So 9 minus 2 is 7, so you have a to the 7th, and 2 minus 3 is negative 1. Well, you're not allowed to have a negative exponent, so we're going to have to send that one down to the denominator. So you have 5a to the 7th in the numerator and just a b left in the denominator. Have a good one.